Hi, I'm Zoe, and today for the Databricks Free Edition Hackathon, I'm presenting a theoretical solar flare grid impact intelligence system aimed at helping power grid operators predict and respond to space weather threats. It uses publicly available NASA space weather data and fault detection training data. Solar flares generate geomagnetic storms that induce electrical currents and power lines, causing transformer failures and blackouts. My solution combines weather monitoring with power grid fault detection to provide predictive intelligence and actionable recommendations. I built the system using Databricks Delta Live tables with a medallion architecture and a basic ML analysis. The bronze layer ingests two streaming datasets using Autoloader. We have NASA space weather observations tracking solar flares by class, intensity and timing, and power grid fault detection data monitoring voltage, current, temperature and equipment health across electrical infrastructure. Both streams can be ingested in near real time. The silver layer performs data quality enforcement. I've implemented expectations that automatically validate and clean the data. For example, for the solar data, we're checking that the timestamps are valid, flare classifications are legitimate, and intensities are within realistic ranges. Any records that fail these quality checks are automatically dropped, ensuring we only work with trustworthy data. In the gold layer to the right, I've created business-ready analytical tables. By joining the solar and grid datasets by date and adding temporal lag features like same day, next day, 2 days later and 3 days later, this captures the delayed effects due to geomagnetic storms that may not impact the grid instantaneously. I'm also tracking voltage drops, temperature rises and equipment health degradation over time. Beyond the correlation tables, I've also added a simple machine learning enriched table set in a few Databricks notebooks, and this allows the model to predict grid failures under different solar scenarios and includes probability forecasts. Now, to make this intelligence accessible to grid operators, I've set up an AI/BI Genie, Databricks natural language query interface. Operators can ask questions in plain English and get instant actionable answers. I'll demonstrate some real queries a grid operations team might ask now. So if we were to ask the Genie to visualize the daily fault types, here we can see our fault distribution over time. You notice how the tracking of different fault types, overloads, short circuits, temperature rises, etc. Each fault type requires different response strategies, so this breakdown is critical for maintenance and planning. They then might ask, what is the daily flare activity? So let's visualize that. Here's the solar flare timeline. You can see the intensity variation, gives a general overview over time. The Genie can also provide some top-level overviews of what the correlations are between the flare activity and the faults within the grid. Within this data, we're looking at a fairly low positive correlation between the two. And then it can also find out what solar flare anomalies we can see, and also visualize those. Now, if we're looking to predict what's going to happen over the next 7 days, this is our probabilistic forecast. Based on historical frequency analysis, we can see the likelihood of different flare classes occurring. It'll give a top-level overview of what may occur and then the data to back it up. Here's our risk threshold guide. When a flare intensity crosses into the X class territory, that's intensity level 15 or above, we hit the critical risk and emergency protocols should be activated immediately. This gives the operators clear, actionable decision points with no guesswork. And now we can also find out what they are to do with suggested actions for the given outcomes. It's giving a top-level overview from the data it's found and then the dataset backing up. So to recap what you've seen, a production-ready data pipeline with medallion architecture and automated quality checks, real-time streaming integration of NASA space weather data and power grid monitoring, machine learning predictions using physics-based modelling with probability forecasts, an AI-powered query interface that makes complex analysis accessible to operators, and most importantly, actionable intelligence with specific recommendations.